Just 2 days prior, 4 astronauts made an ocean landing in the Pacific, marking the first time in over 5 decades that humans had journeyed to the moon and successfully returned. Artemis II has concluded. Its capsule now rests on the deck of the USS John P. Murtha, while Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen have returned to Houston. The astronauts are undergoing medical examinations by flight surgeons, while the heat shield is being meticulously photographed inch by inch. And inside the Vehicle Assembly Building at Kennedy Space Center, another rocket is already under assembly. NASA isn't pausing to celebrate. They cannot afford to, given that the mission following Artemis II is so incredibly ambitious, so technically demanding, and with such a compressed timeline that the agency is essentially asking itself to achieve in 2 years what it had spent the previous decade preparing for. What most people don't realize is that the April 10th splashdown wasn't merely the conclusion of a mission. It served as the starting signal for the most aggressive lunar campaign since Apollo. So, what exactly is NASA building toward? 3 missions in roughly 2 years? An unprecedented lander test, a crewed lunar landing for the first time since 1972, and the establishment of a permanent base at the moon's south pole. All of it hinges on hardware that, as of today, has never transported a human being. The immediate priority is the heat shield, specifically its performance during Artemis I in November 2022. The uncrewed Orion capsule returned with its Avcoat heat shield significantly damaged in ways nobody had predicted, with charred material having broken away during re-entry, leaving divots and cracks across the surface. The shield still protected the spacecraft, and internal temperatures never exceeded design limits. However, the damage pattern did not align with the computer models, which caused apprehension for Artemis II. NASA then modified the re-entry profile to limit the time Orion spent in the temperature range that caused the issue. Engineers shortened the skip distance, the arc the capsule traces when it bounces off the upper atmosphere before plunging back in for its final descent. It worked. The crew returned home safely. But during the post-splashdown news conference on Friday night, Orion program manager Howard Hu confirmed what everyone expected. The shield came back with divots and cracking again, signs of uneven ablation. Divers were in the water within minutes, photographing the damage, and aircraft tracked the capsule's fiery re-entry to capture thermal data in real time. NASA knew this was coming. They flew the mission anyway because they believed the underlying structure would hold, and it did. The 4 astronauts hit the atmosphere at Mach 33, roughly 25,000 miles per hour, endured a 6-minute communications blackout, while plasma wrapped around the capsule at temperatures that can reach up to 5,000 degrees Fahrenheit, experienced nearly 4 Gs of deceleration, and splashed down right on time. At 8:07 p.m. Eastern, approximately 1,956 miles downrange from where they entered the atmosphere off the coast of San Diego. All parachutes deployed, all systems functioned as expected, and the crew disembarked from the recovery helicopter unassisted. The mission itself was almost perfect. Over a period of 10 days, Artemis II commenced its journey on April 1st at 6:35 p.m. Eastern from Kennedy Space Center, with the crew spending their initial day in a high Earth orbit. After conducting system verifications, they ignited their engines to propel Orion towards the moon. 3 days subsequent, on April 6th, the craft rounded the far side. During that close approach, coming within approximately 4,070 miles of the moon's surface, they recorded features on the far side that no person had ever directly observed. They captured images of craters, peaks, and geological formations previously known solely through data from robotic orbiters. And then, at an entirely unforeseen moment, something remarkable occurred. While the mission was initially slated for a February launch, the moon passed between the spacecraft and the sun, creating a total solar eclipse visible from beyond the lunar body. Victor Glover described the sight as unreal, with the total eclipse enduring for almost 54 minutes. Additionally, they surpassed Apollo 13's distance record, traveling 756 miles from Earth. That particular record had remained unbroken for 56 years. Hansen, who previously served as a fighter pilot in the Royal Canadian Air Force, achieved the distinction of being the first Canadian to ever journey beyond low Earth orbit. Cook, who already held the record for the longest continuous space mission by a female, having spent 328 days aboard the International Space Station, achieved another pioneering feat. Glover became the inaugural black astronaut to travel to the Moon. However, the problem with the heat shield remains unresolved. This issue is currently under investigation, and it isn't the sole concern. During the press conference following splashdown, mission leaders identified multiple systems requiring scrutiny. Prior to the launch of Artemis III, the Orion service module necessitates a valve redesign. The lavatory experienced a malfunction during the mission, an issue that appears insignificant, until one considers that 4 individuals are confined within a capsule, comparable in size to a large SUV, for 10 days, without any means of opening a window. Amit Kashyapria, NASA's associate administrator, conceded that the schedule is demanding. Approximately 15 months separate the present from Artemis III, and the agency continues to gain knowledge regarding how to operate at the speed required by its own timetable. His remarks were direct. Keep flying, keep learning, keep iterating. The solution for the heat shield, specifically, involves a re-engineered abcoat composition featuring enhanced permeability, which is already being incorporated into the Artemis III and IV spacecraft. The current dilemma for NASA is whether the information gathered from Friday's re-entry, when combined with the Artemis I data, provides sufficient assurance to approve the updated design. Without conducting an additional uncrewed test, the resolution to that query will determine the entire future schedule. Artemis III is the next mission. However, it differs from common perception. For an extended period, Artemis III was anticipated to be the pivotal mission, marking humanity's inaugural lunar landing. Since Gene Cernan re-entered his lunar module in December 1972, 2 astronauts were slated to touch down at the Moon's South Pole using SpaceX's Starship human landing system. The mission was planned to involve approximately 1 week dedicated to gathering samples and performing experiments, followed by a return to Orion in lunar orbit, initially slated for 30 days. This ambitious plan, representing the most intricate human spaceflight ever conceived, was scrapped. In January 2026, NASA formally postponed Artemis III, pushing its launch to at least 2028. However, a mere 5 weeks subsequent to this announcement, on February 27th, NASA Administrator Jared Isaacman completely reversed course. Artemis III's launch was advanced to mid-2027, with a significant caveat that it will not journey to the Moon. Far from it. Instead, Artemis III will deploy a 4-person crew aboard an Orion spacecraft, launched by the Space Launch System, into low Earth orbit. There, they will endeavor to achieve something unprecedented with these specific vehicles. The crew will perform a rendezvous and docking maneuver with either one or potentially both of the commercial lunar landers. These landers, specifically SpaceX's Starship HLS and Blue Origin's Blue Moon, will have been launched independently on their respective rockets. The astronauts will then physically board these landers. Their tasks will include testing the propulsion systems, assessing life support capabilities, verifying communications, and, for the very first time, donning the new Axiom Extravehicular Mobility Unit, EMU, spacesuits. These are the suits intended for future lunar explorers to wear on the Moon's surface. Consider this mission a full-scale dress rehearsal for the Artemis program, a comparison NASA frequently draws to Apollo 9 in March 1969. During that mission, astronauts Jim McDivitt and Rusty Schweickart piloted the lunar module in Earth orbit for the inaugural time, conducting tests of rendezvous and docking procedures, as well as performing spacewalks in the suit. This was the very suit that would be worn on the Moon 4 months subsequent. While Apollo 9 rarely receives the same recognition as Apollo 11, and isn't remembered for its drama, Apollo 11's success would have been impossible without it. Artemis III serves as precisely that kind of mission. It's the critical testing environment for all the equipment designed to transport humans to the lunar surface. And currently, as of this week, NASA has yet to make a final decision regarding whether the mission will dock with a single lander or two, or if it will operate in low Earth orbit versus a higher orbital path. The latter would more accurately replicate thermal conditions near the Moon. Furthermore, the choice of which company's vehicle will be utilized first remains open. These determinations are partially contingent upon the speed at which SpaceX and Blue Origin are able to prepare and launch their respective landers. SpaceX faces an immense challenge. Its Starship HLS must first achieve orbit and then undergo refueling via a minimum of 14 distinct tanker flights originating from a pre-established propellant depot, which SpaceX is also responsible for constructing and filling. Each of these tanker flights necessitates the use of an additional Starship. The intricate logistics involved in transporting such a substantial quantity of liquid methane and liquid oxygen into orbit, followed by its transfer between vehicles that have never before executed an orbital fuel transfer using crew-rated systems, and subsequently propelling the fully loaded lander to rendezvous with Orion, all within a constrained launch window, represents an engineering challenge that would have appeared insurmountable a decade ago, and it may still prove to be so. In contrast, Blue Origin's Blue Moon lander employs an alternative strategy, being smaller and in certain aspects more conventional. However, it also has yet to fly with a human crew. Both companies are required to complete uncrewed demonstrations of lunar landings before NASA will permit astronauts to board. A report issued in March by NASA's Office of the Inspector General revealed that it was observed that these test runs won't entirely reflect the actual crewed spacecraft, implying that the initial occasion these landers transport astronauts in their definitive setup could be the real mission itself. Should neither firm be prepared on schedule, NASA faces a significant challenge. Artemis III, lacking a lunar lander, ceases to be Artemis III. It merely becomes another Orion mission. Provided the lander trials are successful, focus then moves to Artemis IV. By early 2028, the inaugural human lunar touchdown in over half a century will occur. 4 space travelers will embark on an SLS and Orion spacecraft, journeying to lunar orbit, where a commercial lander, either Starship, HLS, or Blue Moon, will already be present, having been independently launched and positioned into an elongated polar trajectory with its closest approach approximately 62 miles above the lunar surface. Orion will connect with the lander, 2 spacefarers will move into it, and they will begin their descent. Then, for the first time since December 14, 1972, human footwear will make contact with the lunar soil. The chosen touchdown zone is slated to be close to the Moon's southern polar region, an area previously unexplored by any human and only a handful of robotic probes. The southern pole bears no resemblance to the level equatorial expanses where Apollo mission crew members move with ease in reduced gravity, bathed in perpetual daylight. The lunar South Pole is characterized by perpetual darkness, with the bases of specific craters having remained unexposed to solar illumination for eons. Within these shadowed areas, temperatures plummet to -390 degrees Fahrenheit. Imprisoned within this extreme cold, as indicated by orbital information from devices such as the Lunar Reconnaissance Orbiter, there exists water ice, potentially in significant quantities. Were one to stand at the edge of such a perpetually shaded crater and gaze downwards, absolute nothingness would be visible. Utter darkness would prevail. There's no atmosphere to disperse light, no luminous reflection, merely an emptiness etched into the lunar surface, sufficiently frigid to solidify carbon dioxide, containing ice that might have been deposited by comets billions of years prior to the emergence of life on Earth. This very ice is why NASA selected the South Pole. Water signifies potable water for space travelers. It also provides breathable oxygen, and by separating water into hydrogen and oxygen, it yields rocket propellant. Thus, the South Pole serves as more than merely a scientific research site. It functions as a refueling point for all subsequent endeavors. NASA has pinpointed 9 potential touchdown zones close to the pole, each encompassing several distinct locations. The ultimate choice hinges on which lander is utilized and the specific functionalities it possesses. Certain locations grant superior entry to areas of constant shadow, while others offer more reliable sunlight exposure for generating electricity. All these areas feature topography considerably more rugged and intricate than any environment the Apollo missions ever encountered. The pair of astronauts will remain for roughly a full week on the lunar surface. They are scheduled to perform a minimum of 2 extravehicular activities, EVAs, utilizing the Axiom spacesuits previously evaluated during Artemis III. Additionally, they will install a seismograph, known as the Lunar Environment Monitoring Station, intended to detect the moon's internal tremors and chart the composition of its crust and mantle. Furthermore, they will gather specimens from a lunar area, previously untouched by human contact. Following this, they will re-enter the lander, ascend into orbit, link up with Orion, and journey back to Earth. The entire mission is projected to span approximately 30 days. Considering the entire mission duration, from liftoff to return, Apollo's longest lunar surface mission lasted 3 days. However, Artemis IV is planned to support 2 individuals on the moon for a full week. Additionally, 4 crew members will remain in lunar orbit for a month. This represents a massive increase in complexity, and the choice of lander for this task hinges on the outcomes of Artemis III. Should SpaceX successfully demonstrate a Starship HLS rendezvous and docking in 2027, and if their spacecraft receives certification, then Starship will be selected. Conversely, if Blue Origin's Blue Moon is prepared and operates effectively, it will be chosen. If both vehicles are ready, NASA will opt for the one providing the superior safety margin. This decision remains pending. It cannot be finalized until comprehensive test data becomes available. And even then, not until after the initial activities at Artemis IV's landing site have concluded. NASA intends to return once more. Artemis V is scheduled for late 2028, merely months following Artemis IV, marking a shift in terminology. At this point, NASA transitions from discussing individual missions to planning for a permanent base. Artemis V will involve the second crewed lunar landing, with 2 astronauts journeying to the South Pole. They will travel aboard Blue Origin's Blue Moon lander. For the first time since Apollo 17, astronauts will utilize a rover, specifically a new lunar terrain vehicle. This vehicle, engineered for the South Polar region, will have been pre-positioned on the surface via an earlier cargo mission. The crew will dedicate approximately a week to exploration, traversing a greater area than any Apollo mission achieved. This is in contrast to the 3 days spent with the original lunar rover. However, Artemis V's primary objective is construction. During this mission, NASA anticipates commencing the physical establishment of infrastructure. This infrastructure is intended for a lasting lunar outpost. While specifics are still under development, the proposed design includes power generation units, communication networks, and mobile platforms. These components will be transported to the lunar surface by automated cargo landers as part of NASA's Commercial Lunar Payload Services initiative. The Artemis V crew will be the initial human team. Their role will be to engage with these pre-positioned systems, activating various pieces of equipment, linking modules, and confirming that the robotic placements are correctly situated and fully operational. Administrator Isaacman has referred to this as the initial stage of a 3-part strategy. Phase 1 involves constructing, testing, learning, and deploying equipment. This includes testing the equipment and identifying any malfunctions. Phase 2 introduces partially habitable structures, such as shelters and work areas, designed to prolong astronaut stays. Phase 3 aims for a continuous presence, with crews rotating through an operational base every 6 months, residing and performing tasks on the moon for periods of weeks. This could extend to months at a stretch. NASA's goal for uninterrupted human residency is set for 2032, by which time the agency foresees extended surface expeditions. These missions would employ nuclear propulsion to investigate craters and areas distant from the primary landing zone. There are plans to utilize lunar regolith, the fine powdery soil covering the surface. This regolith would be used for 3D printing structural elements and for extracting oxygen, water, and other raw materials. The moon will cease to be merely a destination. Instead, it will transform into a production facility. This involves an investment of $20 billion across 7 years, numerous missions, and commercial collaborators launching cargo at an unprecedented frequency for lunar activities. A nuclear reactor approximately 10,000 times weaker than a standard Earth-based power station, yet compact enough to be placed inside a vehicle. It's deployed on the surface to maintain power throughout the 2-week lunar night, a period when solar panels are ineffective. Isaacman, in fact, declared just prior to the Artemis II launch that NASA is constructing an experimental, nuclear-fueled spacecraft designed to arrive at Mars by late 2028. Its goal isn't to land, but rather to validate the propulsion system's viability. Regardless of its success or failure, the collected data will be directly integrated into the Luna program. The Luna Gateway, that orbital space station positioned close to the moon, which NASA had been developing for years, has been abolished. In March 2026, the agency opted to reallocate its financial resources and engineering expertise towards the surface base instead. Components and equipment initially conceived for Gateway are now being adapted for new uses. The emphasis is on the ground, not space, on human presence, not experiments conducted in an orbiting vessel. While orbiting 250,000 miles from assistance, the SLS rocket itself almost met its end. In May 2025, the Trump administration's proposed budget advocated for the termination of both SSL and Ariane following Artemis III, due to the rocket's approximate cost of $4 billion per launch. For several months, the entire program's prospects, beyond its initial 3 missions, remained uncertain. Subsequently, on July 4, 2025, the One Big Beautiful Bill Act was enacted, and within that legislation, funding was discreetly included to ensure SLS and Ariane could continue operating past Artemis III. The rocket endured, yet this incident exposed the precarious political support underpinning such a costly endeavor. Each election cycle, every fiscal dispute, and any alteration in White House priorities presents a potential existential threat to Artemis. Meanwhile, a competition is unfolding, which largely goes unnoticed by the public. China's lunar initiative is progressing rapidly. They have already successfully deployed robotic probes to the moon's far side, an accomplishment unmatched by any other nation. They have also retrieved samples from the lunar surface. Their declared objective is a human lunar landing by 2030, with subsequent plans for establishing a permanent base. NASA's schedule, assuming it remains on track, would see Americans on the moon 2 years ahead of China's arrival. Should there be any delays, that advantage disappears. However, none of this is assured. The heat shield must function correctly with its updated composition. The landers must successfully launch, and SpaceX needs to master orbital refueling on a scale never before attempted, involving 14 tanker flights to replenish a depot that doesn't yet exist. Blue Origin, for its part, must provide a spacecraft that has never previously launched. The Axiom suits are required to operate effectively in environments impossible to fully reproduce on Earth. Furthermore, Congress must continue to finance a program costing billions annually during a period of unyielding budgetary constraints. And all these elements must align with a timeline that presumes virtually no significant setbacks. Every component in this sequence must succeed. Yet, standing here just 2 days post-splashdown, the overall situation appears more distinct than it has in years. Artemis II demonstrated that Orion is capable of sustaining 4 individuals in deep space for 10 days. It also confirmed that the heat shield, despite its imperfections, can safely return them from lunar return speeds. It demonstrated that the Space Launch System is capable of sending a crew on a lunar trajectory and bringing them back. It also confirmed the effectiveness of the European Service Module. Extended by Airbus in Bremen, Germany, It successfully powered and propelled the spacecraft for almost 700,000 miles of round-trip journey without any significant malfunction. All the systems upon which future astronauts will rely for reaching the lunar surface have now undergone human testing, a state that was not achieved just 2 weeks prior. During the flyby, Wise named a crater in honor of his deceased wife, Carol. In a moment that surprised even mission control, the crew subsequently named another crater after their spacecraft's integrity. After requesting authorization, they received approval from Houston. These instances were significant, serving as a reminder of the program's true purpose, which extends beyond mere data collection or engineering achievements. Instead, it's about broadening the horizons of human exploration, what people can discover, and what they can construct upon arrival. In 15 months, assuming all goes according to plan, a different crew will board Orion. However, they will not journey to the moon. Their mission will involve remaining in Earth orbit to rehearse docking procedures with a lunar lander. This lander is intended to transport the subsequent crew to the lunar surface. While it lacks glamour, won't establish new distance records, and may not even gain traction on social media, for more than a single day, it represents the foundational mission that enables all subsequent endeavors. Following this, lunar landings will commence, occurring approximately annually.